Today we're going to talk about reflecting triangles in a coordinate plane and then writing algebraic rules or representations for that. So pay attention and work with me. We all have our worksheet. The first part says graph a point anywhere in the second quadrant of the coordinate plane and label it point A. Well, let's make sure you remember the quadrants. Our first quadrant is right here where both x and y are positive. Our second quadrant is here. We go in a counterclockwise direction. Third quadrant and fourth quadrant. And look, we've used Roman numerals to represent our quadrants. We are making a point, graphing a point anywhere in the second quadrant. So this would be over here. Let's pick this point right here, where x is -5 and y is 7. Graph the point, label it point A, and write the ordered pair, -5, 7. And let's go ahead and record it in our table. The original point coordinates are -5 and 7. And remember, with our ordered pairs, the x coordinate comes first, the y coordinate comes second. It says, let's reflect and graph your point across the x-axis on the coordinate plane, and we're going to label it point A prime. Remember, the x-axis is the horizontal axis, so let's reflect. When we reflect, the new point will be the same distance below the axis as the original one was above. Right here, this point A is at 7 units above the x-axis, so our new point A prime will be 7 units below. So I'm going to stay right where x is -5 and count 1, 2, 3, 4, 5, 6, 7. So this will be my new point, and I'm going to label it A prime. And hopefully you know they have the same x coordinate. It's still -5. Trace down, you can see it's right there at -5. But now my y coordinate is a -7. So let's put that here. Reflect across the x-axis. X is still -5, but now y is -7. Hopefully you notice when we go across the x-axis, our x coordinates stayed the same, but from our y coordinate, it was the opposite. So the way we show that algebraically is we say, well, our x coordinate didn't change, but we took the opposite of the y coordinate. So across the x-axis, x stays the same. Make a note on your paper. X stays the same, and we take the opposite of y. The second direction tells us to reflect and graph my point across the y-axis and label it A double prime. So here's our original point. If I go across the y-axis, I have to travel the same distance on the other side as it is on this side. It is 1, 2, 3, 4, 5 units on this side. So it's going to be 1, 2, 3, 4, 5 units on this side. And as you can see, if you look down here, the x coordinate is a +5 now. The y coordinate is still a +7. And this is A double prime. So come down to your box, and A double prime has a positive x value and a positive y value. Here it says, let's write a rule for a reflection across the y-axis. Well, hopefully you notice that this time the y coordinate stayed the same, but instead of having a -5, I have a +5. So I know I took the opposite of my x coordinate. And this is how we show it. When we reflect across the y-axis, we take the opposite of x, but y stays the same. And let's write that down. This time we took the opposite of x, but we have y stays the same. On this page of our handout, they're asking us to use patty paper. It says use your patty paper to trace triangle ABC. Well, before we use our patty paper, I want us to come down to our table and list the coordinates for our original triangle. If we have point A right there, we can see that x is 3 and y is -4. So let's write down 3, -4. B, right here, x is 6 and y is -1. And then for C, if you come all the way there, x is 4 and y is -9. Now remember, when we do a reflection, trace your triangle and then flip it over. A reflection is a flip. So go ahead and take a minute, flip your patty paper and trace. Since you can't see me flip my patty paper, I'm going to use what we learned on the front. When I reflected across the axis, the point was the same distance on the other side of the axis as it was originally. So I'm just going to do that with each one of my points. B is here, one below the x-axis, so I'm going to put B prime, one above the x-axis. And then I'm going to take A. A was 1, 2, 3, 4 below it, so I'm going to make it 1, 2, 3, 4 above it, and that'll be A prime, B prime, and A prime. C was 9 below it, so I'm going to make C 9 above it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that was my C prime. And hopefully you noticed I kind of traced along the lines here to make sure that I didn't lose my X coordinate. And then I'm going to connect it. And then after I trace it, after I count, I can always use patty paper to make sure I haven't changed my shape. So I have triangle A prime, B prime, C prime, and A, B, C. And now I'm going to list the ordered pairs for my new points. A is at 3, +4. B is at 6, +1. And C prime, I've left that prime off, is at 4, +9. And we can see that the rule stayed the same. When I go across the x-axis, my x did stay the same, but every one of my y coordinates is now the opposites. Let's test the reflection across the y-axis. This is what we're doing now. We're going across the y-axis, and we're going to see what happens. If I start with point A, I can see that A is here. It is 1, 2, 3 units across the y-axis. So I'm going to go 1, 2, 3 over here, and this will be A double prime. B is 1, 2, 3, 4, 5, 6 on the right, so I need to go 1, 2, 3, 4, 5, 6 on the left, and that'll be B double prime. C is 1, 2, 3, 4 on this side, so I'm going to go 1, 2, 3, 4 over here. That'll be C double prime, and when I connect those, I have my new triangle there. Now you should use your patty paper, trace, and make sure that the shapes are still congruent. They've just been flipped over. And if we look at our ordered pairs, A double prime is at x is -3, y is -4. B double prime is at x is -6, y is -1. And C double prime is at x is -4, and y is -9. Now we always compare to the original, and we can see that on triangle ABC right here, x was 3, now it's the opposite, but y stayed the same. 6 was our original x, we now have -6, so it's the opposite of x, but y stayed the same. And on our last point, 4 and -9, we have the opposite of x, but y stayed the same. So our rules do match what we did on the first page. When we go across the x-axis, x stays the same. When we go across the y-axis, y stays the same. I want you to do the next two. We'll do the next problem, number 3, and then come back and we will talk about it. Okay, I hope you did this and you're just checking your work. If you follow exactly what we did above, the new coordinates for D, since we went across the x-axis, should be -7, -10, -5, -5, -1, +8. And it said, how do I determine the coordinates of the image without actually graphing them? There's a rule that we used. The rule that we used said we know that x is same and that we use the opposite of y. And the way we show that algebraically is we say our original point was xy. Our new point would be x is the same, no change, but we took the opposite of y. And don't forget, this doesn't mean y becomes opposite. It means take the opposite of y. So if it was positive, it becomes negative. If it was negative, it becomes positive. Let's see how you did on reflecting across the y-axis. Your new ordered pairs should be +7, 10, +5, 5, and +1, -8. And now we need to practice writing an algebraic rule for this. And our rule would be that when we go across the y-axis, we take the opposite of x, and y is the same. And we write our rule like this. Our original point was xy. After reflecting across the y-axis, x changed. So we take the opposite of x, but y stayed the same. And remember, this minus sign does not mean negative. It means opposite. So if x was originally negative, as it was here, it became positive. So it's really important that you remember that. On this last page, we just have a little extra practice. We have quadrilateral, A, B, C, D. Quadrilateral is just a shape that has 4 sides. And I'm going to reflect this across or over the x-axis. So remember, I'm going to be going down. I'm going to start with point A. Hopefully you can notice that point A is currently 1, 2, 3, 4, 5, 6, 7, 8 places above the x-axis. I'm going to go 8 below. So I'm going to start on there. 1, 2, 3, 4, 5, 6, 7, 8. And that would be A prime. We always use a prime mark to show our new points. B is 1, 2, 3, 4, 5, 6, 7. And I know it's 7 because look, the y value is 7. So I'm going to go 7 below. So instead of being at a +7, it's going to be down here at a -7. But I like coming along here because it makes sure I don't mess up where I am. 1, 2, 3, 4, 5, 6, 7. So this is B prime. And I'm going to go ahead and connect those. A goes to B. C is only 1 above, and now it's going to be 1 below. And I'm going to connect B and C. That's C prime. D is 1, 2, 3 above. Now it's 1, 2, 3 below. And that's D prime. So there's my new shape. If you use your patty paper and trace it, remember you flip the patty paper over. We're not sliding down, we're flipping. We flip the patty paper over to check it. And my ordered pairs are this. My original point A was at a -6, +8. My new point A, it still has an x value of -6, but now it's at -8. B is at -2, +7. My new point, B prime, is still at -2, but now I'm all the way down there at a -7. C is the easy one to check. It's at -6, 1. My new point is still at -6, but now it's at -1. And then D was 1, 2, 3. It's at -8. positive 3, and d prime is at negative 8, negative 3. And hopefully you noticed all of my x values stayed the same. X stayed the same. All of my y values have gotten the opposite. So my rule is x stays the same, but we take the opposite of y, and that's when we go over the x-axis. On this quadrilateral DEFG, my original points are D is 3, 6, E is 5, 2, F is at 3, negative 2, and G is at 1, 2. Well, we're going across or over the y-axis, so we would expect y to stay the same. So we should be taking the opposite of x, and we expect y to be the same. Let's see if that's what really happens. If that's the case, I should be at a negative 3, positive 6. Let's find out if that's where d prime goes. Here's d prime. 1, 2, 3. So I'm going to go 1, 2, 3, d prime. And I'm at negative 3, positive 6. I would expect e prime to be at the opposite of x, would be negative 5, but y would stay the same. E is right here. I am 1, 2, 3, 4, 5 there. So I need to come 1, 2, 3, 4, 5 here. There's e prime. And it is at negative 5, positive 2, just like we predicted. All right, moving on to F. F is at 3, negative 2. So we would expect to find the opposite of x. So that would be a negative 3, but keep my y. It's still going to be a negative 2. Let's count. F is down here. It is 1, 2, 3 away from the axis. So I'm going to go 1, 2, 3 away from the axis on this side, and this will give me F prime. And I'm going to go ahead and connect. And if you look, I am at now negative 3, negative 2. My last point is G. G is at 1, 2. If I take the opposite of 1, I'm going to get a negative 1. My y should stay the same. It should be at a positive 2. So let's move it. G is right there, 1 from the axis. Let's go 1 on the other side. This gives me G prime, and I'm going to connect. So I have G is now at negative 1, 2, just like we thought. If you look at use your patty paper, hopefully you drew a little bit better line than me. If you use your patty paper and flip it over, you should find out the shape is exactly the same. It's just been flipped over the y-axis. The algebraic rule for reflecting a figure across the y-axis is that we take the opposite of x, but y stays the same.